Okay, good afternoon. Welcome to the first session of the spring 2020 semester of Sunoikisis Digital Classics. This semester is convened by myself, Gabriel Bodard, and Dimitar Iliev from the University of Sofia. And each of the next 9 sessions will have different presenters and speakers. This week, we're going to be talking about some basic tools for digital classics, for digital humanities, some essential tools which we hope students will then be able to use throughout this semester and throughout any other digital work they do. So this is not so much an introduction of a new research method, as most of the sessions will be, but a general introduction to a couple of essential tools. We're going to talk about using the command line to navigate your operating system. We're going to talk about using the Git version control system and using the example of GitHub. We're going to give you a basic introduction to regular expressions. And we're going to introduce the concepts of open data, open licensing, and data repositories with a brief introduction to the Journal of Open Humanities Data at the end. The final part will be presented by Barbara McGillivray, who sadly isn't here with us live today, but will be joining us via a short video. The presentations today will be by myself and Katharine Shields from UCL, who's also with us. Also in the call today are Dimitar, who's the co-organizer of this session, and Valeria, who was the convener of last semester and is today going to be pretending to be a student and asking us lots of questions as we talk about these introductory tools. Those of you who are following live on YouTube, there is a live chat box, should be up in the top right of your YouTube window. Please do leave messages there, say hi, let us know you're watching, and ask us any questions as you go on. Because we're introducing some fairly basic tools and concepts today, it's really important that that you understand what's going on. So if at any point we're going over your heads, that's our problem, and you really should stop us and let us know so we can try to cover that. Okay. I guess I should start with a brief introduction to the use of the command line. So the point about the command line, both on Windows and on Mac, although they work in slightly different ways, is that most of the things that you can do by clicking, dragging, double-clicking, etc. on your desktop and on Windows in your desktop, you can also do in the command line by typing commands of one kind or another. So if you're opening a file, if you're moving a file from one folder to another, if you're creating a new directory to put files in, deleting a file, renaming a file, all these are things that you can do from the command line. The advantage of working on the command line is you have slightly more control of what you're doing. A lot of the time, it's less intuitive to those of us who have grown up using a mouse and dragging things around the screen. But it's a slightly more old-fashioned way of dealing with things. The one difference is that, and I'm going to try and open my slides in the background as I'm talking, so bear with me as I slow down. Is that on the Windows command line, what you're basically doing is you're using commands in this terminal window as shortcuts to small applications that live on your hard disk, which run the processes that you're asking it to do. Whereas on the Unix command line, which is what the Mac uses, but also any Unix-based operating system such as Linux, you're actually speaking to your operating system using the command line. So there's slightly different things going on. You won't notice that difference for basic things like moving around, but sometimes especially when trying to install things, trying to figure out why there might be a Java conflict in some software you're installing or something, having the command line and having that sort of root level access to your operating system will give you slightly more control over what's going on. That's not something that we're going to cover this week, but that's something that might come up in future weeks that might be useful for you to talk about. to know how the command line works. So just a couple of quick points about the command line then. On a Windows machine, you find the command line by clicking on the either the run command or it's the Windows button, I guess, in the bottom left-hand corner of the screen. It used to be called Start, but it changes with every new version of Windows. I forget what it is in Windows 10. And you either type command line or just CMD, and it will open this this command window for you. I will do this in a moment on the screen and show you what a command window looks like. And the basic commands that will navigate around in your drive folders in this command line environment are the ones that I've given you here on this slide. The ones in green are the ones that you're most likely to want to use and that you might want to experiment with now as you're getting used to the system. And as you'll see in a second, they're very, very similar on the Mac. They're almost exactly the same commands. One or two of them are very slightly different. They may just be spelled differently, for example. We'll show you those differences in a sec. So the main command that you're going to have to use almost every time you start up the command line is cd. Cd changes the directory. This basically takes you from one place to another. It's double-clicking on a folder to open it. It's navigating around, finding the right folder, double-clicking on it until you get to the right place. And the way you use this is you simply type cd, and then based on your current context, you type the name of the folder that you want to get to, a backslash, and the name of the folder within that you want to get to, and so on as long as you want. So the example that I will show you in a minute, I have on my desktop a folder that I've created called test, which has a few files in which I will mess around with, and that I will do that by opening my command line, which opens in my root directory by default. If I say cd desktop, it changes my directory to desktop. And then if I either type cd directory backslash test, or I can type cd directory and then a new command cd test, it'll take me into the test folder. Okay, so that's how I move around. I can type cd and then the folder. If I want to go up a directory, so come out of a directory into the directory that I started from, or the directory that's above it in the hierarchy, as it were, I can type cd ... and that will take me up to the parent directory. And that's fairly standard syntax and worth knowing. If at any point I want to know where I am and what else is in the folder that I'm currently in, because I'm not looking at the folder on my desktop as I would be in if I were browsing in Windows, I can type the directory command, which is dir, which will give me a readout of my current directory, and it'll tell me all the folders and files in that directory. And it might tell me a little bit about those folders and files, such as their size and their last edited date and so forth. So that's dir for directory. I can then do various things. I can delete files using the del command. I simply type del and the name of the file. I can copy a file. For that, I need to type copy the name of the file, and then the name of the new file that I want to copy it to, which might be in a different place. So I might type its entire file path there. Move, similar to copy, except it gets rid of the original version when it moves it to another place. And rename, simply as the name says, renames a file in the same place as it currently is. Then there are the commands for making a new directory. mkdir is make directory, make a new directory, and rmdir is to remove a directory, to delete a directory. Note that Windows won't let you remove a directory if it is not empty. So you have to delete all its content first, or you use some subcommands to say, remove this directory despite the fact that it's got content in it. So this is basically to stop you making mistakes and deleting an entire section of your hard disk by typing the wrong thing in. And finally, if you want to know more about any of these or any other commands that you can use on the command line, you can simply type help. Either on its own, it'll give you a list of all the commands that are available, or help followed by the command you want to know more about, and it'll tell you just more about that command. Okay, so that's the basic overview of the Windows command line. I will demonstrate this in a minute with a command window on the screen, so you can see an example of that in action. Most people, I think, that are watching this are likely to be using Macs. So a few differences between that and the Mac operating system are indicated on this slide. Most of them are the same. You open your terminal either from the Launchpad or from the Applications folder. And once you have the terminal open, you can navigate using the cd command, exactly the same as on Windows. Note that unlike on Windows, on a real operating system, on any Unix or Mac-based operating system, there'll be a / in between folders rather than the backward slash. The command to list the contents of your current directory is not dir, but ls for list. And the commands for delete, copy, move, and rename are slightly different in that delete is rm for remove, I guess. cp is short for copy, mv is short for move, and there is no rename command because to rename something, you simply move it to a file of a different name in the same place, and that is renaming. In fact, I just tested it on a Windows machine. That's exactly the same. Move and rename are two commands that do exactly the same thing. So rename is redundant anyway, and so it doesn't exist on the Mac. mkdir and rmdir for make directory and move directory are the same, as well as help on the Windows machine. On the Mac machine, and you can also use the man command to get the manual entry for the user manual entry for the command you're looking for. So you can say man make directory to get all the things you can do with the make directory command. Okay. This slide should really be considered the default. So I'll get rid of all the red. This is really the default. The peculiarities of the differences between the two are weirdnesses of Windows, not weirdnesses of Mac. So Mac and Unix are really how these things should work. And even on a Windows machine, if you're using a bash tool to run Git, as we've recommended in the session page, you will probably be using Mac commands anyway. So this slide actually is the one that's more useful to you than the Windows one that I showed you 2 slides ago. So what I will do now is I will show you very briefly a couple of these functions in operation in the command environment, which, if you give me a second to reshare a different part of my screen, application window, command prompt. Okay. I'll show you what happens. So this is what happens when I first open my my command line on a Windows machine. It takes me to what is called my home directory. Okay, it's the directory marked. I'll just clean the page. Right, this is what it'll look like. It'll be my home directory. It's the directory in users that has my name. That's the name that the computer calls me by, this is the directory in which things like desktop and the documents folder can be found. So I can look what's in this folder using dir, and that shows you all the various things that are in here, including, as I say, desktop, documents, downloads, all those sorts of folders that you're used to seeing on your machine. Or I can change directory into one of those folders. So I want to go into my desktop. As I said, I put this folder called test on my desktop. And I then type a / to get to say I want to go to something inside desktop. And one thing that works on both versions is if I start typing test, but I can't remember whether I called it test or whether I called it test with a number after it, because I use tests for all sorts of things, I can start typing and then press the tab key on my keyboard and it auto-completes the rest of it. In fact, if I press just T and tab, it will auto-complete quite a lot of the rest of it. In fact, because I only have one folder called T on my, which starts with the letter T on my desktop, it auto-completes it straight away. So if I press enter, then that takes me into the test folder. Note that everything before that angle bracket there, before the flashing cursor, is my current file location. So I'm in users, my username desktop/test. I can see what I've got in this test folder. And what I've got in this test folder are 2 text files called Latin Inscriptions from Sardinia and Terence Hisira, which you will be seeing again later, but which we'll ignore for the moment. And then I've got 4 text files that are called text1, text2, text3, text4.txt, respectively. And those are the files that I'm going to play around with now. So I'm just going to use a couple of those commands that we've seen in the thing so far. So I can use the delete command, del, to remove text1. Again, I'm only going to type the first part of that, and I'll press tab to complete the .txt at the end because that's easier. So that deletes it, and if I dir again, you see that it's no longer there. It's now only giving me the first two, the Latin and Terence, and then text 2, 3, and 4. So I've deleted the file. I can then rename a file, so I can say rename text2, and I say what I want you to rename it to, so I'll rename it to something more verbose, just for the sake of argument. And when I look at the directory again, you see I've now got I have no longer got a text2, but I've got a second text file .txt. A couple of other commands just very quickly. I can make a directory called, I don't know, let's call it subdir just for the hell of it. So now you can see there's a directory listed in the directory listing there, and I can go into that directory and look what's in there. There's nothing in there, it's empty, so I'll go back to the parent directory. And what I can do is I can then move text3 into that new directory backslash, and I have to give it, I just have to say what name I want to call it when I move it in there, and I will keep the same name in this case. So I say move it into there, then when I dir, that's no longer here, but if I cd into the subdirectory and get the dir, you see the text3 is in there, okay? Last thing I'm going to show now is back in the in this directory, which has got various text files. It's only got txt4 now, and the subdirectory. I'm now going to remove the directory subdir, and it'll say, no, I'm not removing the directory because it's not empty. And so I can say something like, if I can remember the command, I can say remove directory subdir, and it's /q, I think, to, it's capital Q. Okay, capital S, I should have checked this. Yes, okay, I can now, it will now let me, just with a check, /S means remove it even if it's not empty. I can't remember what the S stands for, but I'll say, are you sure? And I'll say yes, and now when I do directory listing, those files are all gone. That directory's gone. That, I think, is all I wanted to check. If I wanted to, last thing I'll show just quickly is I'll show you the help command. When I was trying to remove the directory, and I was trying to force it to remove a non-empty directory, I couldn't remember what that subcommand followed the thing after the slash was. I thought /q meant quiet, meaning it'll do that without even asking me if I'm sure, but that clearly wasn't it. So if I do help rmdir, it'll tell me what the options are. Actually, yes, /q is quiet. It does. That should have removed it for me. But maybe I'd have to say /s and /q. I can't remember. But anyway, you can do that, and it'll give you the commands that you're looking for. Okay, so I'll stop there. That's just a very quick overview of what the command prompt looks like. Katie, do you want to very quickly show a couple of, not all of that, but just a couple of those commands on the Mac command prompt, just to show a slight difference there? Okay, sharing your screen. Yep, you're still muted.
Oops, unmuted. Okay, so that's unfortunate.
There's no dir,
sorry.
of course. It's
I started with the wrong one. Okay, so list to show show what's in the directory, and then I'm going to do /desktop, and then again, sorry, I'm messing this up.
ls first. Yeah.
ls first, and then desktop. Sorry, I don't know what I'm.
Don't include the slash, because that's taking you to the root of your computer.
There we go. Okay, so I found what's in the desktop, and in the desktop, I have a folder called text files. So I'm going to list what's in the text files.
But your context is still your home directory, so you need to, if you're ls, you need to include desktop in the command because you haven't cd'd into it. Yeah.
Okay, so I have two texts in there, and they're called Headcaira and inscriptions. I'm going to, first of all, rename using the move command. So and then I want to rename it as Terence, the name of the author, instead of the name of the play. So for that, and then now I've got two files called inscriptions and Terence, and then I'm going to delete the file called inscriptions. Okay, and now I only have one inscription left, one file left called Terence. Is there anything else that you want me to demonstrate?
No, I think that's good. That gives people the general sense of the difference between the two. Yeah.
Okay.
Great, thank you. Unless Valeria, as our token pretending to be a student today, has any questions before we move on?
Yes, just pretending, of course. Can I ask either of you, Gabby or Katie, to show once again how to go up in your tree? Like if you want to go to a more general thing, because
yeah, so
I'm currently
in this screen. I'm currently in the test folder, as you can see from my command line, and I can move back to the desktop folder by typing cd ... And that takes me up one to the desktop folder. Yeah, and I can do that again and go up one to my home folder. Or if I'm in desktop, I can just type cd ... and then go to my documents folder, for example, to navigate all in one go. Does that make sense?
Yes, perfect. Thank you.
Cool, great. And that would be exactly the same on the Mac. There'd be no difference at all. Okay, back to my other screen share of my slides.
Can I intervene to ask a question?
Yes, go ahead, Mika.
What about file extensions? When you're not using the command line, when you're using something like Microsoft Windows, the file extensions go by default, and you either cannot change them, or here you have to type them. Can you reformat a file or repurpose it, make it to open under a different program if you type a different extension? Can you manage your files like that in the command line?
Probably, but I couldn't tell you how. Basically, if Windows hides your file extensions from you, that's a really bad thing. And I know Windows does most of the time. I always set it not to at the very beginning. It's somewhere in the Windows options. I don't even remember where, because I last changed it 4 years ago when I got a new Windows computer. But yeah, that's the command line will not hide the extensions from you. But if you don't know what the extension of a file is, you can always press tab when you're halfway through typing its file name, and it will tell you all of the files that you could be looking for if your file name is still ambiguous. But in terms of changing it to be opened with a different piece of software, that's editing the file options, which you normally do by right-clicking on the file and selecting preferences, or similar in on the Windows desktop. That there must be some way to edit those sorts of options, but I'm not sure where those actually live in the file. So I'm not sure I would use the command line to do that.
So you cannot just change the file extension by retyping it and hope that it will be.
You can rename the file extension. You can rename the file to having a different extension. Again, that's usually a bad idea, because the file extension, especially in Windows, is an essential part of that file's identity. If you have a document file called that's called .doc, and you change that to be in .txt, Microsoft Word will no longer know how to open that file. Whereas on a Mac, it'll still know that it's a Word file and that the extension is just a bit weird. But on Windows, it will just not know how to open that, and you'll have broken your file. And if you can't see extensions in your folders, then you've got no way of fixing it either. So probably best not to do that. Okay, let's press on, as that's taken a little bit longer than we planned to. I'm going to talk now about a version control system. I'm going to talk about the Git version control system, and for this, I'm going to first talk a little bit theoretically, and then I'm going to show you the GitHub environment, just to give you a sense of how that works. So, a quick overview of Git commands. A Git a repository is basically a database containing both a set of files and a set of information about how those files have been changed since they were first created. And so what the various states of these things are. So when you first create a repository, it is empty, you add files to it, and each change you make to it is recorded explicitly, both who made it, when it was made, what comment you made while you made it, and enough information to be able to reconstruct the file at every stage of its history. And this is really useful for collaborative projects, but it's also useful for work where you want to be able to potentially roll back if you make mistakes that you might not discover until weeks later, and also useful for sharing files across multiple machines. So I use Git sometimes for projects that are not collaborative, just because I'm using 3 different computers, and I might want to work on one from a different place. So the first thing you do if you have a Git repository and you want to take a copy of it onto your desktop, you use a command that's called clone. So you clone the repository onto your desktop. What this looks something like this, second line here. So you say git clone, and this you do from your command line. You navigate into the folder where you want to put the new copy of the repository, and you say git clone, then the address of that repository. And if you wanted to get the Sunoikisis repository that we're using for this year's training courses, you can use the address given here, github/Sunoikisis/Sunoikisis2019-20.git, and then after that you put the title of the folder you want to move to clone it into, and this whatever new folder you might want to create there. And this then will, even if you don't have the rights and the privileges to commit to this Git repository, you will still be able to clone it and use its contents and work on its contents locally. Okay. Then when you're working with a Git repository, so if it's your own repository or someone else's repository that they've given you privileges to be able to work with, the most important commands you need are the 4 commands that I've given you here in yellow on the slide. The first is the command you want to do basically to make sure your local copy is up to date with any changes that other people might have made or that you might have made from different machines to the version of the repository that's on the server, and that is the command pull. So you say git pull any changes that might have come into the thing since I last updated, and pull them down onto my machine so I get all the things. Pull will also very usefully check for conflicts. If you've made any changes locally since you last pulled, that that conflict with changes that other people have made and committed since you last pulled, then it will check that and say, no, I can't pull because there's a conflict. We've both edited the same file in different ways, and there's something that needs to be manually fixed before you can do that. So it's quite important to always pull before you do anything else. Even if you think probably no one has changed anything, pull anyway. Then there are 3 commands. The following 3 commands are all related to putting your changes, your local changes, onto the server, onto the default version of the repository, the home version of the repository on the server, on GitHub, in this case. And these are, first, tell the repository which files of those that are different on your local system than they were when you started, you want to commit the changes to. So you might have made some changes to files that you're not interested in committing. Some files might have just been changed by accident. You know how computers sometimes change some files when all you've done is look at them. You don't want to commit those changes, so you're only adding those files that that you've explicitly said you want to be added. There's also the command git rm for remove, which is similar to the rm or delete command on your operating system. And this means don't just remove it from my operating system, but remove it such that next time I commit, Git knows to remove it from the repository as well. You can bypass the add and rm commands by, when you commit, adding the tag -a, and that commits and adds all in one go. But that's potentially dangerous. What that will do is that will add any files which were in the repository when you last updated and have been changed. It won't add any new files that might have appeared in your folder since then, but it will tell you about those files, so you can choose to add them before you finish committing. So then the commit command will basically take any of the changes that have been added, or all of the changes automatically if you use the A tag with it, and it will push them to your local version of the Git repository. Okay, and this means that it gets a version number. You can always roll back to that version number at any point you want to. The git commit command has a required tag, which is this tag -m, which is for a message, because you always need to have a commit message. And this is where you summarize in very, very few words what it is you've done. Adding a file, edited to update authors, whatever, something very short like that. And finally, you can stop there, you can just commit and you can use it as a local version control system on your own computer. But occasionally, maybe not every time you commit, but sometimes you're going to want to push the changes of your commits on your local version of the repository to the home version of the repository on the server. And that you just use the git push command. And that will take all your commits and it will send them to the command. It's important that if you've committed anything at all, then after committing and before pushing, you also do a git pull again, which will check for any conflicts. And potentially, pull will often automatically merge those conflicts. If they're conflicts in the same file but not on the same line as the file, it'll just take the most recent version of each line and merge them all into a single document, which is really useful. So you pull, you add, you commit, you pull again, and then you push. Okay, is it clear? Do you think are people pretending to be students that process, what those 4 commands mean? Okay, for those who can't see, they're nodding. Okay, great. A couple words about project management then, the way people use Git. Git is can be used in various ways. If you're working largely on your own and in a project that is not also being deployed live to people who are using this software and who are downloading it regularly, then probably what you want to do is you just want to work in that core version of the repository, and every time you make a commit, you make a change, you simply add it, commit it to that repository. If you're making a series of changes, incremental changes that are potentially going to break your code until you've finished making them, then you might want to nevertheless put them in as multiple commits, so you've got all these options for rolling back and seeing where the errors might have come in, but don't push them to the repository until you're fairly happy about them working. So if you actively break something, commit it multiple times while you're trying to fix it, but don't push it until you've fixed it, at least good enough that someone else comes along and looks at it, doesn't find a broken software in the repository. Okay, but that doesn't need much by way of project management there. If you're working in a project which has slightly more active use than that, you may be one of multiple developers on that project, or it may be a project that people are using quite regularly, they're downloading the software from it, and the version that is in the repository on the server, it's quite important that that be a good version. Then what you might want to do is use a Git command called branch, which enables you to make another version of the repository alongside the main one, the root one, and be working in that. So anything that you break or anything that isn't fully tested or anything that's not optimal is hidden from the main branch until you feel it's fine, and then you do something that's called merge, and you merge your branch back into the root of that repository. Okay, so that's what's meant by branching, where you take your work, your repository, and you make two branches of it, one that's for public use and the other that's for development, and then you merge them usually fairly soon after. The third version is where you want to contribute to a repository that is not yours, and maybe you don't have commit rights to that repository at all, but you can clone it. So as long as you can clone it, what you can do is, rather than just cloning it to your desktop, you can fork it by cloning it into another repository, and then you can make all sorts of changes to it there, and those changes may never find their way back into the original repository, or if you want them to go back, you can make what's called a pull request, which is where you say to the owners of the original repository, look, I've made these improvements to your code, would you like to include them in your repository? And they can look at them and they can decide whether to include them or not. In all of these cases, you will sometimes find that when you're attempting to push, when you're attempting to merge a branch, when you're attempting to issue a pull request, there will be conflicting commits. I will have committed something to the main branch, someone else will have forked it, made some changes, and those changes are not compatible with one another. We'll have to look at them and say, I need to fix that. Okay, so that we will sometimes need to resolve that conflict as we go. For those of you working on this for Sunoikisis, you probably will just use the first option. You won't need to branch or fork. So I'm not going to explain how to do those, but these are ways in which people work using Git. Any questions about this from the gallery before we move on? No? Okay. So I'm now going to very quickly share a different part of the screen. What am I sharing? I'm sharing the GitHub tab there, which confusingly means I can't see this window anymore. Okay, back. So this is my GitHub account, and I've got 3 repositories in this account, as you can see here that I work on. When you first create your GitHub account, you won't have any repositories in here yet. So what you'll probably want to do is you'll want to create a new repository. So I'm simply going to click on New over here. You can't see where my cursor is on the screen, but I've clicked on the New button, and the green New button in the top right of the screen. There's my cursor. And this has given me the various options. So I can create a new repository either in one of the projects that I have responsibility for, or in this case, as in your case, just in my own directory. And I'll give that repository a name. And let's say, you know, ICS02 class work or something. So this will be a repository that you create. That you can put in there. You can give it a description if you want, that's optional. You can keep it public or make it private. I would keep it public. We're not going to put anything sensitive in these repositories. And if you initialize the repository with a README file, this means that that the repository is not empty when you start it, and you can immediately make a clone of it onto your desktop. So I would simply select yes and then click on create repository down there. I'm not going to create a repository. I would suggest you do but I'm not going to, because I've got too many repositories already in various places. What I'm going to do is I'm going to show you what it looks like when I use the GitHub desktop client, which we've also suggested you install to look at an existing repository. So for the example there, I'm going to use the this is not showing you the GitHub desktop client, is it? It's showing you a blank window. Man, how I love Windows. Oh, now it is, strangely. But a bit oddly, so I'm going to change that and show the entire screen instead. Okay, that is what I'm seeing in the GitHub desktop client on Windows. On the Mac version will have slightly different skin, but this basically shows me, and I'm looking at the Sunoikisis Digital Classics 2019 to 2020 repository. This is the repository that has the various slides and various other files that you'll be wanting to use. And you can see down on the left all the changes that have been made to this repository in the past, or I can see here any changes that have been made on my local computer that I haven't yet committed and pushed to the repository. In this case, there are none, which is good. And I have this button up here, which is Fetch Origin. Now, one thing to note, and this is the only thing I really want to stress here, is that when you're using the GitHub client, rather than using the command line to type those Git commands that we saw earlier, this button, Fetch Origin, will simultaneously pull any changes from the server and push any changes that you have committed back to the server. So you can't first pull to see what happens and then decide whether to push or not. It does both for you automatically. Okay, so if you want a little bit more control over what you're doing than that, then maybe use the command line. Okay, that's part of the reason why the command line is more useful than the server. So I'll stop there because we'll talk more about this a little bit at the end, and also we probably want to. This has taken much longer than we planned, and we do want to give Katie time to talk about regular expressions. So handing over to you, Katie.
All right. So I'm going to be talking about regular expressions. So I'm going to put up the slides to start with on my screen.
Yep, they're up.
Great. Okay, so regular expressions are something that describes a pattern to find text or position within a string of text. And they can be used to search for text, to find or replace it, or to validate text against a particular pattern. And they're something that's used in most programming languages with minor variations. So it's sort of an extremely useful basic function. So regular expressions are made up of things called literal characters and special characters. Literal characters are things like uppercase A, B, C, D, E, or lowercase letters, or numerals like 1, 2, 3, 4, 5. And regular expressions are case sensitive by default. As well, there are special characters like the backslash, circumflex, $sign, the dot, and so on. And these characters have different functions when matching strings of text. So for example, the dot matches anything apart from a new line. It doesn't automatically just match a dot or a full stop within the text that you're searching. And the question mark, the asterisk, and the plus sign are quantifiers. So they're matching things a number of times rather than matching a question mark. So moving over to the next tab. So I'm using Regex 101 to just briefly demonstrate this. So if I want to search, for example, this text taken from the Sunoikisis page and I want to find the word Sunoikisis, I can type in Sunoikisis here, but it's not going to find it because it always begins with a capital letter. So if I change it to Sunoikisis with a capital letter, then it finds both examples. And then what if I wanted to find everything in brackets? Well, the brackets are a special character, so it tells me that there's a pattern error, that it's an incomplete group structure. So if I wanted to find one of these special characters literally, if I wanted to find every open brackets in the text, instead I can put a backslash before, which is an escape, which says if it's followed by a special character, to take this special character literally, and instead it finds here all of the open brackets within the text. This escape function also works with some other characters as well as an escape before a special character. An escape can create shorthands for characters or character classes. So the letter W, if it's just by itself, it matches the letter W. With a backslash in front of it, it stands for a word character. So any uppercase or lowercase letter, any digits, or an underscore. The lowercase letter D with a backslash before it stands for any digit 0 to 9. Backslash S is a white space character, so any white space character, including a tab, and just a tab is backslash and T, a return, which is backslash and R, a new line, which by itself is backslash N, and backslash F, which is form feed, so the next section or the next page, and backslash S matches all of them. You can also find a particular specified Unicode code point with backslash U followed by the 4 characters for a particular code point. So, for example, backslash U0041 would match uppercase A. But this is one thing where there's a bit of variation between different implementations. So the backslash U and then the 4 characters works for most of them, but if you're using regular expressions in Perl or Perl compatible regular expressions, then what you need to use instead is a backslash X and the curly brackets around the code point. If you want to negate one of these shorthands, you can put the letter in uppercase, so backslash D finds any character that isn't a digit, backslash W finds any character that isn't a word character, and backslash uppercase S finds any character which isn't a white space. Finally, there's also backslash B, which finds any word boundary, i.e. the start or end of any alphanumeric sequence. So these are useful things to more efficiently to find different strings. So going back to the same example text, say I want to find all of the numbers, all of the digits. Here I can do backslash D, and then that finds all of the numbers within this text. If I want to find, for example, 2 digits in a row, I can just do backslash D again, and then it finds any sequence of 2 digits. And then maybe I also want to find all of the characters that aren't word characters, so all of the things like spaces and commas and the punctuation. I can do backslash W, and then that finds the spaces, the colon, the ampersand, and so on. And then if I want to perhaps find a particular letter at the beginning or end of a word, I can use the backslash B to find all of the breaks. And then if, for example, I want to find a lowercase m at the start of a word, there it just gives the m at the start of May and markup and so on. Okay, so then quantifiers. So in the last example, I repeated backslash D to find 2 digits, but there's other more efficient ways of saying how many of a particular character you want as well. So a question mark, first of all, makes something optional. So that means 0 or 1 occurrences. So a /d followed by a question mark would find either not an occurrence of no digit or 1. The asterisk is any number of times 0 or 1 or more than 1. The plus sign is 1 or more, so at least 1 occurrence, and then you can use numbers in curly brackets to specify exactly how many times either a range, so with a comma between, or a particular number. So for example, if I did open curly brackets, 2,5, and then close the curly brackets, that would be at least 2 but no more than 5 of the thing that I'm specifying. And when you have a group in parentheses, you have to put the quantifier outside the group to make it apply to everything within the group. So if I move on to the second example here, which I've taken of the information of an inscription from Sardinia. So say I want to find in this text all of the modern dates mentioned. I think the modern dates are probably going to be a sequence of 4 numbers. So I can do \d for numbers, and then using the curly brackets, I can specify a sequence of exactly 4 digits. But because this is also maybe going to find ones that are part of a longer string of numbers as well, I can put the break before and the break afterwards, so to find a sequence of exactly 4 numbers here, which unfortunately gets me a page number as well as the years. But then so if I'm looking for then the page numbers, so the page numbers here can be preceded by either P a dot and a dot, or PP and a dot for a series of page numbers. So I want 1 or more P's, so rather than putting 2, I can put PP. Okay, well that's also bringing up some other instances of 1 letter P in the middle of a word, but I know I want it followed by a dot. So I can do the / and then the dot. So there are that finds all of the page numbers within the information about this inscription. So as well as quantifiers, we also have groups and ranges. So a range is indicated with square brackets, and the square brackets mean any of the things inside the square brackets. So here, the first example here, I've got A, B, C inside the square bracket means match any one of A, B, or C. The hyphen specifies a range. So 0 to 9 inside square brackets means any of the numbers including or between 0 to 9, and A to Z is all of the uppercase letters. So ranges are always inclusive. You can use a circumflex to negate a range. So with the circumflex before the range A to E means anything apart from the letters A, B, C, D, and E. The brackets, the parentheses make a group, so match everything within the group. So this means match the sequence A to B, and the vertical line within the group can be used as an OR operator. So it means match anything that's either the thing before the line or the thing after the line. So here, match anything that's either A or B.
So in that example, Katie, just quickly, am I right in saying that parenthesis A pipe B close parenthesis would be the same as saying square brackets AB close square brackets? Basically? Yes, basically. In this case, although there might be times when this is part of a longer regular expression, yes, where it might be important to specify the difference, but when it's just by itself, it does mean exactly the same thing. Yes. Great, thanks. And I think I've got an example of when you need the either or later. Okay, so quickly back to then demonstrate
here. So if I want to find all the capital letters in this description, I can do the range A to Z in uppercase. If I want to find all lowercase vowels, A, E, I, O, U in square brackets. And then if I want to find, for example, all uppercase letters followed by an A or an E, so I can find all uppercase letters and then A or E. And then if I try the alternative here, okay, in this case, the square brackets does find exactly the same thing. And then the final slide here for anchors and back references. So the circumflex and the $sign are anchors. They find things that are the beginning of the end of a string, and a line break is always the start or the end of the string. You can also use back references, which is a backward slash followed by a number. In some versions of Regex, it can also be a $sign followed by a number. So if I wanted to, for example, find either the letters A, B, or C repeated, so a sequence like AA, BB, or CC, I can put all of those in a group as either or options, and then the backslash and the one means the first group, so the first thing with brackets around it. So this is looking for a sequence of either A, B, or C followed by either A, B, or C, but the same as the first one. So to demonstrate that, so if, for example, I wanted to find all of the double digits in this text, so I've made each a digit is a group. This is the first group, so then I put backslash 1, and then it finds all of the double digits, so the 7s there, the 2 7s in 1977, and so on. And then using the anchors, if I wanted to find all of the uppercase L's at the start of the line, I can use the circumflex for the start of a line and then uppercase L. And then there's a few examples there. Okay, so that covers all of the basic regular expression functions. And now I'm going to move on to some demonstrations of longer regular expressions, some uses of them with some other text. And for this, I'm going to use the Atom text editor. So Atom. Here we go. So first,
could you maybe make the text a little bit larger there? It's a little bit hard for us to see on the screen.
Is that better?
That's brilliant. Thank you. Yeah.
Okay. So here I've got a text of Terence's Hakaira, which I've taken from the Latin library. And looking down at the start here, what I found is a problem with this text is that in this very first bit, the text always uses a U for the before a vowel at the start of the word or between two vowels, whereas in the rest of the text it uses a V as well, and this is an inconsistent spelling that I want to get rid of. So first of all, I need to think about how I'm going to find all of the U's used before a vowel or at the start of a word. Okay, to find U is the thing that I'm looking for. Okay, there are a lot of U's in this text. So for a U at the start of either at the start of a word or preceded by a vowel. So within, I'm going to make a group and I'm going to make two options within a group. Either it's going to be preceded by a space, or it's going to be preceded by one of, in square brackets here, A, E, I, O, U. And then after the U, it's going to be followed by also either A, E, I, or O, U, because it's also ones that are also followed by a vowel. So here I found all of the bits in the first this first section of the text where it's different to the rest. So then I want to replace all of the U's here with a V. So using the find and replace function, which is one of the most useful things to do with Regex. So the Regex version of Regex and Atom, if I want to use the back reference to the groups with this, I've got to use a $sign instead of a backslash. So a $sign and the 1 for the first group, because I want to keep what was preceding the U, either the vowel or the space. And then I want to replace the U with a V, so I can put a V in there. And then I need to make the vowel following into a group as well to say keep the second group. So there, and then group 2. So it's found all, and then I should be able to replace all of the examples there. So replace all the rest. So there, I've replaced all of the U's in the first bits with B to make the text a bit more consistent. Okay, so something else I might want to do is find all the proper names in the text. In this text, I think that probably all people and places have the first letter capitalized. So I'm going to clear this and find any capital letter. So I want A to Z. Okay, and then I want, so that I don't also get things like here, the title of each scene or the number of each scene. I want it to be followed by any lowercase letter. And then I want to capture the whole of the rest of the name. So I want one or more lowercase letters, so I'm going to use plus. Okay, that gets me all of the names. If I didn't know that actually this does what this gets all 240 names in this text, maybe I'd want to put a word boundary before to make sure if, for example, I thought that there might be random capitals spread out through the random capital letters spread out through the text as well. It would be better to include a break to avoid including those. Okay, so then what if I wanted to find all of the forms of a particular verb within the text? So if I wanted to find all the forms of credo, I believe. So hopefully this is one where the stem always stays relatively the same. I want cred followed by, and here I can just put any sequence of one or more letters. So I want to find all the various conjugated forms. So I've got 28 results here. So credere, credidi, credam. But this is a case where I really do need to put a break before, because in line 475, it also picks up incredibly, which might come from the same root, but it's not a form of credo that I want here. So I can put the B, and then this appears there's only 27 examples. There we go. Again. Okay, so now I've got a couple of more complicated examples. So what if I wanted to find the word quid in a question? So, okay, quid 115 results. So I want quid to be the start of the word, so I avoid things like quiz quid. I'm only interested in quid. And then followed by any character, any number of times, and then a question mark, and I need to remember to escape the question mark. Okay, but this doesn't get all of the possible questions. Because if we look at line 244, what happens here is that quid then followed by a question mark, but it doesn't stop when it gets to the question mark. It swallows up all the possible characters until it gets to the last question mark before the end of the line, because a question mark is one of the things that can be represented by the dot that means any character, but it also dot means any character but a line break. So if I had any questions with quid that ran over a line break, then this would also miss them. So what can I swap the dot here for? So if it's going to be followed by something that's not a question mark, it'll be followed by a space and then another word. But then this edition also uses things like punctuation to show things like abbreviations and elision. So I'm going to add all of these characters as well, that I know will appear in the rest of the question. But so I need to make this a space followed by any combination of these, followed by one or more of those. But then I might have a question that's just quid followed by a question mark with no other word in the sentence. So then I need to make all of this a group which is optional, that can appear 0 or more times. There we go. So that should get all of the questions and with quid in them there. Okay, so I can do two things to make this more complicated. What if I wanted to, first of all, search with the questions with all the possible singular forms of quiz, not just quid, but quiz and quem and quo and things like that. And then second of all, what if I wanted to also capture the rest of the sentence of the preceding quiz as well? So here we have eho num quid nam, and what if I want this to also match the words before? So first of all, I'm going to make this find all of the singular forms of quiz. So they all begin with either a QU or a CUI. So I'm going to make those two options within a group. And then I need to add on the possible endings for these. So I can have qui, quid, this, quem, quo, and then qui could be qui or quius, so then I can just make quius optional. Actually, I can simplify this even more because I can see three of these endings have an I in them, so I can replace the I with either I followed by D or I followed by S, and then make that group optional. So that then will give me either qui, quid, or quiz. And then to include the words before quid as well as after quid, I can pretty much just copy across this group here, which has captured the words afterwards, but I just need to move the space. Move the space from the end to the beginning. So then here you can see now that this has captured echo, num, quid, the whole thing, and a question with 4 minutes, the question that's only quid, and it's so on, and it can catch the even with a comma before it. Okay, so now I've got a couple of examples with some Latin inscriptions. So here I've got a collection of several Latin inscriptions from Sardinia. I've just got the text, and then I've got the reference number, so I want to tag all the reference numbers. Okay, all the reference numbers begin with EDR, and then they're followed by a series of digits, so digits and more than one. And then I've found the 4 numbers, and then, okay, I want to add the tag reference, for example, just ref around this. So I can put the tag ref, and then in here, this is the first thing that the first group, so I can put the $sign and the 1 to refer back to the group, and then I can replace all of those with ref, or ref and red with the typo. There we go. Okay, and these inscriptions have a lot of abbreviations, and I want to find all the words with abbreviations. And they're expanded with the parentheses in the text. So I need, first of all, to find them at least one upper or lowercase letter. So A to Z, A to Z plus, or in fact, in this case, because all of the abbreviations only have word characters with them, I could even find the word characters, and then, okay, this is going to be followed by some brackets. I need to remember to escape those with 1 or more words inside. So I can just copy this over to between the brackets. Okay, that's found all the words with abbreviations, but actually sometimes there's text outside the abbreviations as well, so I need to add the possibility for more word characters after the brackets 0 or more times. But then this then misses out the ones where there's the second set of brackets, so that's going to become one or more times, so this whole thing can go in brackets, so the plus, which then captures, so this whole sequence might appear 1 or more times, so it can capture things like Price-a-day and quinquennalibus, which are expanded multiple times. Okay, I think this might be time to stop the examples.
Before you delete all those, could you add those, especially those longer queries that you put onto a new slide at the end of your slideshow, so that people can copy and paste them to experiment with? Because I think those will be really useful to play with. Thank you.
Mm-hmm.
Any questions from the AirSat students in the chat, or anyone else watching on YouTube? I see someone did ask if they could ask a question earlier, but haven't asked it yet. So carry on in the meantime.
Yeah, that was great. I look forward to trying it.
It's all clear.
Thank you. Yeah, thank you. I thought that was really useful and really clear. The examples, I think, made it, right? Because you can list all those rules, but with the examples, it then becomes really pretty clear what's going on. Note also for the those watching that we have on the session page, we've given a couple of links to overviews of regular expression rules. In one case, there's a cheat sheet, I think. In another case, there's a summary. Both of those, I think, are also very useful summaries of those, including lots and lots and lots of things that Katie didn't talk about because they're more advanced and less immediately useful at this point. Shall we go straight on to the final part of this then? We're running a little bit behind, but I think that's fine. Final part of this, so Barbara McGillivray, who is a researcher at the University of Cambridge in the Alan Turing Institute, couldn't be with us here live, but has recorded a short video for us, which I will attempt to stream for you and share the audio. And she's talking about repositories and open
Hi
data.
everyone, my name is Barbara McGillivray and I'm from the University of Cambridge in the Alan Turing Institute. And today I'm going to say a few words about data publishing and data licensing. So we can think of the traditional research process schematically as represented here. So we have some sources, whether they are texts or artifacts or dictionaries, other scholarly inputs, and these are processed, whether they're read or whether we create some decode, we analyze the data, and we go back and forth, and in the end we publish the analysis in a prose article, which describes the analysis and also interprets the results and maybe builds a theory. So what is left out of this process? There's a lot of effort that goes into creating resources. For example, corpora of texts take a long time to create, but they are of immense value to the community. And these resources don't really have an easy, it's not easy to find a home for them in publishing. Most articles and most editorial policies would require the authors to describe the resources as used in a specific context and then draw some analysis and some results. Whereas there is a place for publishing the process of creating a resource, a description of this process, and that is the data paper. So if you have created, for example, a corpus or a database of information that no one else has, then it's a very good idea to share it, and to share the data, and also write a paper that describes the data. Another aspect that is missing in the traditional research process is that of additional data sets. So in the process of analyzing the data, you may create new data. For example, you may take a portion of a corpus and annotate it manually for the specific phenomenon you're interested in. Or you may correct someone else's analysis in more detail and come up with a data set. Again, whether to publish this? Well, a data paper is a place where you can publish these additional data sets that are created along the way. And that not only ensures that your work is credited and recognized, but it also means that other people are more likely to use the data that you've created and can reproduce your results. So an example of a data paper that is relevant to digital classics is this paper that I wrote with Alessandro Vatti and was published in the journal Research Data of the Humanities and by Gabriel. And this paper I can actually open it here, is basically a description of how the corpus was created and all the decisions that we took to select the texts and to annotate them, for example. So it's a very schematic text that gives all the information that one would need if they want to use the corpus. So there isn't space for a case study or an application of the corpus to a specific research question, but it is really a description of the data set and the resource, with all the detail that would otherwise not find space in a traditional paper. And that is it's one example of a data paper. So once you've decided to write a data paper, then there are some steps that you can take. You've chosen the journal. That at the moment there are two data journals specifically for humanities research. One is Brill's journal. The other one is the Journal of Open Humanities Data. The next step is to find a place where to deposit your data, and that's typically repository. A repository is a place that hosts the data, and it's important that the repositories are chosen so that they are relevant to the data that we're talking about, and they are sustainable. So they should have funding and plans in place to ensure the long-term preservation of the data, because you want the data to be in a safe place. And they should also allow open licenses, because that is critical to make sure that other people can reuse the data. And finally, they should provide persistent identifiers, for example, digital object identifiers or DOI. Once the data is in a repository and it receives a DOI, then that DOI can be used to refer to the data in the paper, the data paper. And then the data paper can describe the data and goes through the usual peer review system process. And then finally it's published, so it will get its own DOI, which you can then use to cite the data paper in the original repository. So the two can be linked that way. And once you have a data paper, you can then use it to cite your data and to cite a description of your data. This was an image, by the way, from the Journal of Open Humanities Data website. So I talked about repositories. So I'm not going to give a complete overview of all the repositories that exist, because there are many of them, but I'll just give some examples. One is Dataverse. So you can find Dataverse at this link here. And Dataverse is an open source application funded by Harvard University. And there are specific instances of Dataverse that are that were built for some journals. For example, the Journal of Open Humanities Data has one instance of Dataverse, but otherwise you can also register if your institution, for example, is connected to Dataverse. And then you can create a data set that receives the DOI, and you follow the relatively straightforward process once you're logged in, and you can deposit the data. Another repository is Figshare, which you can find at this link. And Figshare is an independent body that is supported by Digital Science, which is a company. But the relationship between the two is such that Figshare remains a community-based science project, which retains its autonomy. So that ensures very good sustainability of the repositories on Figshare. Figshare is free to use for everyone, and it allows up to 1 gigabyte of private storage. So you can upload your data on Figshare. This is an example of a data set that I have uploaded onto Figshare, and it's about semantic annotation of ancient Greek. So it contains a subset of the Diaoris's ancient Greek corpus, which was further analyzed from the point of view of semantics. And the information about the data set, the very basic information is contained here, some metadata, license, which I'll say a few more words about later. And once the data are in Figshare, they receive a DOI. And then the process is again quite straightforward. Finally, I will talk about Zenodo, which is another repository. It's free to use, and it's developed and operated by CERN under the EU-funded OpenAIRE Plus project. It assigns DOIs to datasets. This is an example of a dataset that I have deposited on Zenodo. So it gives basic information, the authors, and can be downloaded by anyone. Here it has its DOI, some keywords, and some more information about where the data was used. It was used in a different article. And the nice thing about Zenodo is that you can link GitHub repositories to Zenodo. So if you have a GitHub repository, you can make a release, and then you can link it to Zenodo and assign it a DOI, which is very good. It means you can get your you make your code citable. In addition to these repositories, there are many more that you can use, and there are also institution repositories. So your institution might have a repository that you're required to use. I mentioned data licenses, and this is very important when talking about open data. What does open actually mean? Well, the Open Knowledge Foundation says that a piece of content or data is open if anyone is free to use, reuse, or redistribute it, subject only at most to the requirements to attribute and share alike. So the idea is that you make your data free to use and reuse others, and others can also create and derive data sets from your data, and they should at most credit you and share or make the license of the derived data sets the same type as the original data. And it's very important to choose an open license for your data, and one that is with as few restrictions as possible. And that is because if you impose some restrictions on the license, then it makes it harder for other people to use it. So, for example, if you choose a non-commercial license, it means that charities would not be able to use the data. So these are 4 examples of open license of open data licenses. They differ because the top 2 have a social requirement for anyone using the data to properly attribute it, whereas the bottom 2 have a legal requirement for that. And other than that, you can see the more details about the different repositories, these links. A CC BY is one that is, for example, very widely used. Finally, I will say just a few words about the Journal of Open Humanities data, which I mentioned earlier. It's one of 2 data journals specifically aimed at the humanities. There are more specific ones. For example, the Journal of Open Archaeology data, still also published by the same publisher as the Journal of Open Humanities data, Ubiquity Press. I am the editor-in-chief of the Journal of Open Humanities Data, so I know this journal particularly well, and we are working on expanding its scope, and we are seeking submissions. So if you have a data set and you want other people to use it more and make people aware of it, and you want to describe the process that went into creating the data, then you can consider submitting a data paper. And this is a URL of the journal, and this is the email address of the journal. So you can contact me at this email address with any questions you have. Thank you very much.
Of course, I'm muted. Thank you. Yes, we've overrun slightly. Does anyone have any final comments or questions before we end this session?
No.
Mitko?
No, it was perfect. It was all clear, I think. I don't have anything to ask or to add.
Okay. So there was, because this wasn't a specific research method session as before, as I mentioned before, the exercise for this session is basically to try out all of the things that we've mentioned, make sure you have a basic understanding of how command line works for your machine, create a Git account either on GitHub or on some other repository if you prefer, and try out some of the regular expression methods that Katie showed you, or try to do some other things on some of the files that we've shared with you in the session page. There's a link to the session page below this video if you're watching this on YouTube. And commit and push your changes and a description of your changes that you've done by regular expressions to your Git account, so that they're available, they can be found there. And those of you who are doing this as part of a class, that will be looked at and discussed as an exercise next week, or whenever your next session is. The readings given for this class are not specifically about basic tools for digital classics. They're more discussion readings about the definition of digital classics and how classicists should engage with digital methods and with digital tools more broadly. They span quite a wide chronological range, so as you'd expect, they have quite a few differences between the approaches they take, so it should make for some useful and interesting discussions. So please do read those to get an overview of the thing. Again, this session is more to set you up for the rest of the semester. I guess we'll leave it there. Next week, we will be joined by Emma Bridges and Dimitar Dimitrov, who will be talking about Wikimedia and Wikipedia used in research. So hopefully see you all next week. Thanks and bye.
Bye-bye.